Hi, and welcome to our new video. Today we are going to discuss about linked list. But before we do that, I'm going to ask you to subscribe our channel if you find this content helpful. So, back to our topic. Linked list is one of the implementation of list data structure in Java. So we are going to overview what is linked list. We are going to see some of the operations that linked list supports. Also, we are going to analyze Bigo notation in terms of these operations. And also we are going to do hands-on demos, such as trying to implement simple version of linked list and maybe some of its operations. Linked list is an ordered sequence of data elements. It can be singly linked or doubly linked. Let's see what that means. On this picture we are seeing linked list which is just singly linked. So we have these three boxes which are elements of the linked list. They are called nodes, and we can see head node, which is the first one in the sequence, and nodes generally have data part and also pointer part. In this case we are seeing next pointers. So this next pointer is to tell which is next element in the sequence, and we can also see that final node has next pointer set to null because there are no more nodes. But unlike singly linked list, in doubly linked list, difference is that each node has the pointer not just to its successor, but also to the previous node, so that we can navigate not just forward, but also backwards. Now let's see some of the operations on the linked list, and let's start with insertion. Let's say we are inserting at head. We have this linked list with these values, nodes, and let's say we are going to insert new node with the value of 1. First step is to change the pointer, next pointer of this new element which we are going to insert, and set it to current head. And the second step would be to change the head pointer so that it points to our newly inserted node, so that it will become new head. But what would happen if we performed these steps in the opposite order? So that we would first change the head pointer to this new node, and if we attempted to somehow access the rest of the elements, it would not work, because if we would just change this head and set it to this new node, we can see that it was referring to the null as its next pointer. So we would never reach the remaining elements of the linked list and they would be just lost. So this is why the order of these operations is important. First we change the next pointer and then we change the head reference to the newly inserted node. Now let's see insertion of a new node, but when we are inserting anywhere else, not necessarily at the head. Let's say we have this linked list and we have this element with the value 4 and we are going to insert it in the middle of 3 and 5. First step is to take the next pointer of the current node and set it to the node with value 5. And second step is to take the next pointer of the node with value 3 and set it to the current node, which we are going to insert. So these two steps are all we need to insert a new node when we are inserting anywhere else and not necessarily at the head. Now let's move to removing a node, and let's start with removal at the head. So we have this linked list and we decided to remove the first element, which is currently the head. So what we need to do is to take this head pointer and set it to the next object, next node. So now the first object is not pointed by any reference and it will be garbage collected within the memory. So this is how deleting of the head node happens. And finally, let's see removing a node when we are removing elsewhere. So let's say we have this linked list and we decided to remove the node with the value 2. First step would be to take the next pointer of the node with value 1 and set it to the node with the value 3. And the second step will be to change the next pointer of the node to be removed and set it to null. So these two simple steps are all we need to take to remove a node when we are removing elsewhere. Now let's analyze these operations in terms of big O notation. Adding an element at the head is big O of 1 constant time because it will always take the same number of steps no matter how many elements in the linked list. Adding an element in general anywhere else is big O of n because only way to perform the insertion is to first navigate through that place, and we have to go through other nodes via the next pointer to reach that particular place. And if there are lots of nodes to go through, our algorithm will take more steps, more number of steps, and that's why it's considered n time operation. Removing from head or from the end is constant time because there will be still same number of steps, just changing the pointers. And removing an element anywhere else is big O of n because still we need to go through other nodes, and if there are lots of nodes to go through, our algorithm will take more number of steps. Now let's implement our own version of linked list. So we are going to create linked list, which is the class, and let's make it generic by adding this t inside this diamond shape, inside angular brackets. And each linked list, as we know, has the node, and let it be also generic type, and let's call it head node. So we are going to hit Alt plus Enter, and we are going to choose Create Class Node. And each node will have a data part, which will be private t data, and also it will have the node part. So it will be private node of type t next, so that it will be next pointer to the next node. And let's also generate public node. This will be constructor, so it will be t data, and this data equals data. We are also going to need getters and setters. And finally, we are going to generate toString method. So we are choosing toString, and let's choose only data part. Now let's get back to linked list, and here let's implement some other methods. For example, if we want to get this head node, it will be node of type t get head, and we can return this head. Now let's implement the method which we talked about in theoretical part. So it was insertion, and let's implement insert at head. So this will be t data, and first out of this data we are going to create this node. It will be called new node, which is going to be inserted soon, and inside this we are going to pass this data as a parameter. Then let's add if statement. So if this head is not null, meaning that head exists, we are going to do new node set next this head. So this head will be next node of the current node which we are going to insert inside this linked list. And finally, this head pointer will point to new node which we just added, so that it becomes new head. And in case that this head is null, meaning there is no head, we are just going to bypass this section, and this head pointer will be directly pointing to the new node which we are just going to add. And in order to see the results of our operations when we demonstrate how they work, we are going to override toString method. So instead of standard procedure of overriding the toString method and generating using ID, we are just going to create this manually. So let's create this method toString, and let's use string builder. So let's initiate string builder. And why are we using builder? Because we are going to append each element, each node of the linked list and print it. First of all, we are going to return it as a string and then print it in our demo. And first we are going to just append this opening square bracket, and then we are going to loop through, and we will have this current node. Current node should start from the head, so it will be node of type T, current node equals this head. So while current node does not equal null, so that it exists, we are going to do builder append current node. And at the same time, after appending this current node, we are going to make current node the next one, so that on the next iteration, current node will become the next element, next node. And we should also check that if current node is not null, then we can also add the comma between these nodes when printing. Because if current node is null, then it means that it was the final node and there is no need to add comma at the end. We should just add closing angular, closing square bracket. So after we break out from the loop, meaning that we are at the end, we are also append this closing square bracket right here. And in the end, we are just going to return builder toString. Please note that this implementation, all of it is just for demo purpose, and it does not have the value for real life implementations, but for understanding the linked list and how it works, it can be useful. So now let's create the main class. And inside main class, we are going to create this main method, and let's choose linked list, which we just created and not from Java util. And let it be of type string, call it list, and initiate. And let's call the method which we just created, inserted head, ABC. Let's hit Ctrl+D, and on the next one, let's add DEF. And finally, we are just going to call SOUT, hit the tab, and let's try to print this. So if we run the program, we can see our elements which we added. So first, head was only this ABC, but on the next method call on line 7, we have new head, DEF, and that's why this linked list starts from DEF node. So it means that our implementation works. You can also go ahead and try your own versions and your own implementations for the remaining methods and operations such as delete. You can also implement search and many more in order to get comfortable with this data structure. So this was our demo part for the linked list data structure. Now let's summarize everything about the linked list. So linked list is an ordered sequence of elements, and it is one of the implementations of the list interface. In Java, linked list is provided as doubly linked list. In terms of Bigo, it can have great advantage over the array list when it comes to inserting and deleting the elements, especially inserting and deleting at the head. For example, if we are trying to insert a new element in the array list and there are already several elements, then all the elements need to be shifted rightwards. And this will cause creation of additional array, and of course it will take several steps of operations. But in case of linked list, we are just modifying the pointers and it always takes constant time. So this can be a great advantage of the linked list over the array list. In general, frequent data modification is the case when we might prefer using linked list over the array list, but of course it always depends on the particular case. And first we really should ask ourselves if linked list is really what we need to use. Otherwise, go to implementation class is array list, unless we have some specific demands. So this was all about the linked list. Thank you for watching and stay tuned for the upcoming videos.